On December 6th, 3 Atlas emitted artificial light while hurtling along its orbit toward Mars. Data from the James Webb Space Telescope show that Atlas is harvesting energy, waking up, self-adjusting its orbit, emitting a narrow band of light, sending repeated UV pulses encoding the sequence of prime numbers, and hidden underneath is a hexagonal lattice framework, all of which make 3 Atlas almost certainly a form of alien technology on the OEP scale. The orbit and behaviour of Atlas follow Fibonacci patterns, prime numbers and mirror signals accompanied by thrust pulses repeating every 17 minutes. Metallic radar echoes the risk of reverse bioseeding, and an exact match with a rendezvous point at Elysium Planitia together with a mysterious secondary shadow. Resonances with ancient astronomical markers, brainwave rhythms in meditation experiments, magnetic pulses and infrasound emitted from inside Mars, an eye shape beneath the sand and molecular traces resembling RNA make 3 Atlas appear less and less like a lifeless rock and more like a key that is activating planetary memory. The fact that 3 Atlas is approaching Mars once again raises troubling questions in the scientific community, and to confront this mystery, we will begin our exploration right now. Telescopes watched Atlas move closer to the Sun, but the brightness barely wavered, as though some unseen hand were stabilizing the output. Where a natural fragment should have sputtered and shed a storm of dust, Atlas seemed to present a smooth, controlled halo of light. If the orbit of Atlas whispered of a distant birthplace, its unyielding radiance hinted at a behavior that did not fit any familiar script. Quiet notes began to appear beside the name Atlas in internal memos, and observatories started reserving precious time without saying why. To understand what Atlas was really doing, astronomers would need eyes that could see not just light, but the hidden heat behind it. Far from Earth, a space telescope waited in the cold, preparing to look at Atlas and decide whether this visitor was ordinary ice and rock or the beginning of a different kind of story. The James Webb Space Telescope rests 1 million miles from Earth, unfolding its mirrors toward the dark like a metallic flower. On a quiet rotation of the sky, Webb is given new coordinates, and 3 Atlas slips into the center of its gaze. Webb was built to read warmth in the cold to weigh the heat of stars and dust, yet at last begins to misbehave in its detectors. For a natural visitor, sunlight should warm the surface, and the glow should fade smoothly into space. Instead, Atlas shines in infrared like something lit from the inside with a thermal profile that peaks beneath the crust and radiates outward. The numbers say that 3 Atlas is not merely scattering sunlight. The spectrum of Atlas curves like an object that is generating energy. Across multiple observations, the apparent temperature of Atlas holds steady, even as distance from the Sun changes more than models allow. A cometary shell should crack vent and cool unevenly, but Atlas presents a strangely uniform skin, as though engineered to keep heat in. On certain angles, the reflected light from 3 Atlas sharpens into narrow knife-like flashes, the kind seen from polished metal rather than dust. Analysts measure the reflectivity of Atlas and find regions that approach the precision of a mirror far brighter than ice, or rock can explain. Layered spectra hint at alloys rich in heavy elements, as if the surface of 3 Atlas had been plated not simply formed by chance. Line by line, the familiar language of ordinary comets begins to fail, replaced by signatures that read closer to structure than to rubble. In meeting rooms where the data from Atlas is quietly passed around, the word shell starts to appear in the margins of reports. Some whisper that 3 Atlas behaves less like a fragment and more like a casing, a housing for systems still hidden from view. If Atlas truly holds ordered metal and captive heat, then the next question is unavoidable. What kind of visitor arranges its own light before crossing the space between stars, and why has that light now arrived here with Atlas? The most unsettling clue in the story of 3 Atlas did not begin with heat or orbit, but with the light itself. Observers tracing the glow of Atlas expected a broad, messy reflection, like every other frozen wanderer they had studied. Instead, the graphs from Atlas narrowed, sharpening into a slim band of wavelengths that looked engineered rather than spilled by chance. In ordinary visitors, sunlight scatters across many colours, but the light from 3 Atlas kept returning to the same tight slice of the spectrum. When teams compared night after night of data, the brightness of Atlas did not drift. The intensity stepped up and down in clean repeating levels. A normal cometary halo should smear those channels yet. Atlas seemed to protect specific tones of light, holding them steady while the object moved. Some of those tones overlapped with bands human engineers reserve for tracking and high-gain communication, a coincidence that no one could comfortably dismiss. Quietly, the description of 3i Atlas slid from reflective body to active emitter, a source that appeared to choose how and when to glow. That sense of choice suggested a system within Atlas, a machinery capable of adjusting the outgoing signal to the changing geometry of the solar system. In late-night discussions, researchers began to whisper about beacons and telemetry, asking whether 3i Atlas might be sending reports back toward an unknown home. Even skeptics had to concede that Atlas behaved less like a mirror and more like a transmitter, wearing a thin disguise of dust and gas. Each new round of cleaning left the emission from 3i Atlas looking deliberate, and that impression forced observers to rethink at last. When the light of 3i Atlas began to fluctuate, astronomers first blamed the familiar moods of the sun. Brightness often rises and falls as icy bodies vent gas, yet the pattern from Atlas refused to match any known script. The glow of 3i Atlas rose in clean steps as distance from the star changed, then held steady like a device reaching a set point. In models where chemistry rules a comet brightens in bursts, shedding material in chaotic storms, but Atlas responded with quiet, measured adjustments. Teams overlaid solar output, solar wind, and the luminosity curve of 3i Atlas, expecting to see a noisy tangle. Instead, Atlas traced a calm line that seemed to track available sunlight, as though 3i Atlas was sampling and storing every photon that arrived. Absence of strong gas signatures meant no familiar combustion, no plumes of reactive ice, only a surface that caught light and a core that warmed in reply. One proposal suggested that 3i Atlas might carry a buried layer, a sea of structures tuned to swallow specific wavelengths with unusual efficiency. In this picture, Atlas drifted not as a passive stone but as a slow, deliberate collector, unfurling invisible fields instead of sails. When 3i Atlas crossed certain thresholds of illumination, the energy curve kinked upward, as though systems within Atlas crossed from idle to active modes. The idea that an interstellar visitor could arrive with its own long-term power source felt unnerving and strangely elegant. A self-maintaining machine would not need fuel tanks, only time, starlight and patience, three things that Atlas seemed to carry in abundance. If 3i Atlas truly harvested energy as it moved, then the earlier bursts of narrowband light might not be accidents at all. They could be the first signs of a long-sleeping architecture inside Atlas slowly waking, as the probe slipped deeper into the warmth of our star. The change announced itself not with a roar, but with a quiet, impossible jump in light. For hours, observatories recorded the same steady glow from 3i Atlas, a calm plateau on their screens. Then, across less than 2 minutes, the brightness of Atlas surged by nearly 40% and held. 3i Atlas did not flicker or sputter during the surge. There was no stutter of dust clouds. Solar wind readings stayed uneventful. No flare lined up with the moment Atlas stepped into its new state. Sensors saw no impact, no fragments peeling away, only a clean vertical rise, and then a new higher constant. Thermal data followed the light. The interior of 3i Atlas warmed in a smooth, coordinated wave that spread outward through the shell. Instead of heating unevenly like a cracked sunlit rock, Atlas behaved like a system shifting from standby into operation. Teams reran the numbers, checking for stray reflections and instrumental drift, but 3i Atlas kept returning the same story. The profile of Atlas now resembled a machine that had crossed a threshold, consuming stored energy and sunlight together. Quietly, some described the event as a switch being thrown somewhere inside 3i Atlas, a slow engine turning on. When orbital specialists folded the new measurements into their models, another disturbance appeared. The path of 3i Atlas no longer traced the original graceful arc that would skim through the system and leave. With the post-flare data included, Atlas shifted by a small but undeniable angle, a course correction written into space. The new track of 3i Atlas bent deeper toward the inner system and closer to the plane of Earth's orbit. Natural forces rarely deliver such a precise, timely nudge, especially in step with a sudden brightening and thermal wake. In control rooms lit by monitors, people stared at plots of 3i Atlas and felt a quiet, shared recognition. The visitor was no longer merely passing through. Atlas had adjusted its lane as if choosing to stay in view. When spectrographs finally had time to linger on the passing light, the spectrum of 3i Atlas began to fracture expectations. Instead of the familiar forest of lines from common ices and dust, Atlas displayed sharp signatures from highly reflective heavy alloys. Analysts saw patterns in the light of 3 Atlas consistent with metals polished to a precision unknown in natural bodies. Mixed among those lines were hints of rare Earth elements in concentrations that made no geological sense for a drifting fragment. Deeper passes over the data from 3I Atlas revealed something stranger still: absorption features that matched no known substance on record. To explain those gaps, some teams invoked compounds that until then had lived only inside theoretical papers on extreme state materials. Each revision of the models pushed 3 at last further away from a simple frozen visitor and closer to engineered matter. The surface of Atlas began to look in the language of the reports like plating wrapped around a concealed structure. In quiet briefings, security advisors were invited to listen as astronomers described the shell of 3I Atlas in careful neutral tones. Questions moved quickly from what is this made of to who built something like Atlas and why send it here. A restricted memo circulated through defense channels suggesting that 3 Atlas should be treated less as debris and more as a reconnaissance asset. The wording never claimed certainty, but the phrase Interstellar Scout Platform appeared in a leaked draft and was never fully denied. For those who had watched the light of 3 Atlas steady itself and the orbit of Atlas bend inward, the idea fit too well. A probe would wear a hardened shell, choose efficient alloys and test reactions long before making its presence obvious. If 3 Atlas truly carried synthetic compounds beyond our periodic tables, then every reflection from Atlas was more than a glow in the dark. Each glint became a hint of design, and each unexplained line in the spectrum pressed observers toward the same uneasy thought. At a modest array in the desert, a small team at the SETI Institute watched the charts of 3 Atlas scroll by in pale green light. The team knew that Atlas had already broken several quiet rules of celestial behavior, and so the group decided to bend one of their own. Instead of waiting in silence, the scientists prepared a focused radio pulse aimed along the projected path of 3 Atlas. The signal carried mathematical constants, a sketch of the periodic table, and simple patterns that any patient mind might recognize. Hours passed, then days, while 3 Atlas continued its slow glide through the dark. No one expected an answer, and yet no one could quite stop watching the instruments that now traced the background noise around Atlas. Exactly 72 hours after transmission, a narrow spike rose from the static, a thin line that matched the timing of the original call. The return from 3 Atlas was shifted in frequency and distorted, but the rhythm of the reply mirrored the outgoing message with unnerving precision. As observatories followed up, a different kind of disturbance began to spread through networks watching 3I Atlas. Guidance systems lost lock at the same moments calibration routines failed together, and the clean image of Atlas turned smeared or blank. Engineers traced every cable and server, but the only common factor in the disruptions was the shared effort to stare at 3I Atlas. The pattern suggested not a passive visitor drifting through our gaze, but a source that might be shaping when and how Atlas could be seen. Around planning tables, the language began to change again, and 3I Atlas was quietly compared to a scout that chooses its own angles. The sense that observers were no longer simply watching Atlas, but being allowed brief curated glimpses set the stage for the next and deeper questions. Soon after, the first reports on 3 Atlas official messages began to thin and soften. A brief note from a major space agency mentioned routine recalibration, but never named Atlas directly. Another bulletin folded the entire episode of 3 Atlas into a bland summary of ongoing observations. In parallel, several journals that had highlighted the anomalies of 3 Atlas quietly revised or withdrew their articles. What remained on public record were neutral descriptions of an interstellar body stripped of the strange consistency Atlas had shown. Behind paywalls and private calls, the arguments about 3 Atlas only grew sharper. While policy and politics blurred the story, a group of mathematicians asked to see the raw tracking data of 3I Atlas. They laid the path of Atlas across time, marking each key event, flare and adjustment on a long silent graph. When they measured the intervals, the distances between highlights in the life of 3 Atlas began to resemble a familiar sequence. The spacing of encounters and maneuvers around Atlas echoed ratios from the Fibonacci series, the same pattern found in spirals and waves, layered on top other events linked to prime number spacings, as though 3 Atlas were stepping through a simple universal counting scheme. The orbit of Atlas no longer looked like a mere response to gravity, it began to read like choreography. In this view, the behaviour of 3 Atlas itself became a signal, a message written in motion rather than sound. Instead of beaming words, Atlas seemed to trace meaning through choices of when and where to turn. For some, this was coincidence stacked upon coincidence, nothing more than mind seeking order around Atlas. For others, one truth about three. Atlas mattered more than labels or scales. Atlas had come, and it had behaved as if it heard, and now, somewhere beyond our reach, something that understands such patterns might be looking back toward the blue world that first blinked at the passing light. For months before the strange behaviour, astronomers had watched a quiet traveller slide toward the sun, charting the slow approach of 3 Atlas. On paper, the path of Atlas looked familiar, another interstellar visitor on a long cold fall toward perihelion. As 3 at last neared that closest point, observatories tuned their instruments to watch the classic brightening and tail formation unfold. The first images of the developing tail around 3 at last seemed unremarkable from a distance. A thin stream extended away from the nucleus of Atlas, just as frozen gases should flee the heat. Only when high-resolution frames were aligned did the geometry of 3 Atlas break the pattern. The narrow plume from 3 Atlas did not stretch away from the sun but leaned toward it, a reversed flare pointing back into the glare. Radiation pressure should have swept material from Atlas outward, yet the stream clung stubbornly in the wrong direction. Engineers checked tracking reversed axes, even reprocessed images in case the field of 3I Atlas had been mirrored by mistake. Every correction returned the same unsettling picture. The tail of 3I Atlas behaved as though something in that plume resisted the shove of sunlight or was being driven by a stronger hidden force. Some researchers proposed exotic dust around Atlas grains, shaped to align with magnetic fields and ignore ordinary pressure. Others saw the narrow tidy jet from 3I Atlas as something more deliberate, an exhaust or emission from a controlled mechanism buried beneath the reflective shell. Where natural comets release tangled fans of gas, Atlas seemed to open a single valve and hold it steady against the star. The backward tail of 3 Atlas became the first clear sign that gravity and sunlight alone no longer explained the scene. From that moment, every new dataset on Atlas would be read, with the possibility of engines in mind. When the first precise orbit of 3 Atlas was locked in, dynamicists expected the mass to follow cleanly from the motion. The trajectory of Atlas through the solar system could be described by gravity alone, but the implied weight behind that path refused to cooperate. According to the way 3 Atlas curved around the sun, the visitor should have carried the heft of a dense solid core. When teams inverted the equations, Atlas came out far lighter than its size, and brightness suggested like a shell pretending to be a stone. The low effective mass of 3 Atlas whispered of hollowness of volume without the expected filling. Rotation data added another layer to the puzzle. 3 Atlas turned once every 16 hours, a slow, unhurried spin for such an elongated traveller. Despite subtle forces from sunlight and gas, the axis of Atlas held steady, with almost no wobble or precession over many weeks. Natural bodies of that shape usually tumble or drift, yet 3. Atlas rotated like a carefully balanced object with its weight arranged on purpose. Spectral analysis deepened the unease. Light from 3 Atlas carried strong signatures of nickel and iron, far richer than those seen in ordinary comets. The outer layers of Atlas appeared to be laced with metals, not dust, as if a shell had been fashioned rather than accumulated. Hints of unusual cyanide-bearing compounds around 3 Atlas pushed chemists to admit they were seeing mixtures rarely found in interstellar debris. Piece by piece, the picture of 3 Atlas slid away from rough ice and rock toward engineered structure and controlled balance. A hollow frame, a weighted skin, a spin tuned for stability, each model pulled at last closer to the idea of design. In quiet rooms, people began to speak of 3. I Atlased, not as a wandering shard, but as something built to travel far and remain intact. The thought that such a crafted object now moved through our neighbourhood set the stage for even more unsettling discoveries to come. Debate over 3 Atlas had reached a point where ordinary labels no longer felt precise enough. Some saw Atlas as an exotic natural object, others as a candidate for technology, and arguments circled without landing. To bring order to the chaos, a team led by a Harvard astrophysicist proposed a new ranking. They called it the Object of Extraterrestrial Probability Scale, a ladder from 0 to 10 that would sort visitors like 3I Atlas. Level 0 was reserved for quiet, well-behaved comets, while Level 10 was defined as confirmed active technology with global consequences. Each anomaly around 3 Atlas became a tick mark on the new chart. The reversed jet, the stable spin, the hollow mass. The controlled light all were given weights. When the dust of the calculation settled, 3, Atlas landed at level 4, a place where natural explanations strained but had not yet failed. Level 4 for Atlas meant that the chance of a fully natural origin had dropped, but the community still had room to doubt. The team publishing the result emphasized caution, yet the number beside the name 3 Atlas changed conversations overnight. A visitor once called unusual was now formally flagged as a possible artifact. Just as the scale focused attention on 3 Atlas, the sky removed the subject. On its course around the star, Atlas slipped behind the sun from Earth's perspective, sinking into a predictable blackout. For several weeks, 3 Atlas passed through a region where no ground-based telescope could watch. Simulations filled the silence, extending the path of 3 Atlas beyond the glare. If the models were right, Atlas would re-emerge on a trajectory leaning toward the orbit of Jupiter closer than before. Around the world, teams prepared to catch the first glimpse of 3 Atlas as soon as the star released the line of sight. The disappearance of Atlas turned the wait into a long, uneasy inhale, a pause before whatever came next stepped into view. After nearly 6 weeks of enforced blindness, the day came when 3 Atlas should step out from behind the sun. Across Earth, the Moon and orbit telescopes that had tracked Atlas before turned back to the predicted coordinates. For a long moment there was only the familiar glare of the star, and then 3. Atlas slid into view again. The first measurement stunned even the most cautious teams. 3 Atlas was almost 4 times brighter than models had forecast its halo sharp and clean. Temperature readings from Atlas, however, told a different, stranger story. Instead of flaring hot and cooling fast, the thermal profile of 3I Atlas settled into a stable plateau. The warmth of Atlas held steady to the decimal, as if some internal regulator were quietly holding a set point. Where a natural comet should have boiled and sputtered, 3. Atlas presented the calm of a system that had found equilibrium. Observers searching for the reverse tail of earlier weeks found nothing. The peculiar inward jet of 3 Atlas had vanished, replaced by a more subtle feature that only showed up after careful filtering. From the region around Atlas there emerged a faint, narrow band of ultraviolet light, so soft it almost hid in background noise. When teams compressed time in their plots, the behavior of 3 Atlas snapped into focus. The UV output of Atlas rose and fell in a clean pattern, repeating with uncanny precision every 247 seconds. 3 Atlas was no longer just bright. Atlas was pulsing as though counting silently in the dark. What looked like a simple flare now resembled a broadcast heartbeat of radiation, timed with machine-like discipline around 3 Atlas. Some argued that stellar activity could have sculpted the pattern, but the exact repetition clung stubbornly to Atlas. As data scientists began to align pulses and search for structure, the mood around 3 Atlas shifted again. The return of Atlas was no mere reappearance, it felt like the beginning of a transmission. In the quiet control rooms, people leaned closer to the screens, sensing that 3 Atlas had chosen this moment to start speaking more clearly. At first, the ultraviolet pulses from 3 Atlas looked like nothing more than a soft, steady tapping. Analysts wrapped hours of data around a single timeline, compressing the faint breath of Atlas into dense bands on their screens. When noise filters cleared away the background, a new pattern began to tease the edge of recognition around 3I Atlas. Peaks in the signal from Atlas did not fall at random intervals. The pulses from 3I Atlas stepped through time in groups separated by gaps that grew in a simple rhythm. Counts of the spacing between bursts matched the small prime numbers that students learn at the beginning of arithmetic. The first run from 3I Atlas traced 2, then 3, then 5, then 7 beats before a longer pause. A second run from Atlas rose higher, adding 11 and 13 before resetting, like a careful teacher repeating a lesson. The odds that thermal noise or solar weather had carved this sequence around 3 Atlas were so small they felt abstract. In meeting rooms, people wrote the sequence from 3 Atlas on whiteboards and stared at the lonely digits. Prime numbers had long been proposed as a universal signature, a way any thinking mind could announce itself through pattern. Now that signature appeared to be riding on the gentle ultraviolet breath of 3I Atlas, looping again and again in the dark. The rhythm suggested that 3 Atlas was not merely responding to sunlight, but running a protocol, a program written in timing. 3 Atlas behaved less like a glowing rock and more like a clock that had been waiting for the right moment to start. Every news cycle strengthened the sense that Atlas was broadcasting a simple, deliberate greeting into the surrounding void. To probe deeper into the source, controllers turned the gaze of a great observatory back toward 3 Atlas. Instruments on Webb were retuned, calibrated to read not only the light, but the structure beneath the reflective shell of Atlas. What those eyes would soon find inside the glow of 3 Atlas promised to push the story beyond even cautious imaginations. The hyperspectral eyes of Webb open once more on the reflective shell of 3 Atlas, searching for structure beneath the glare. Layer by layer, software peeled away the glowing skin of Atlas, turning raw photons into a 3-dimensional map of hidden geometry. Beneath the bright crust of 3, at last a pattern emerged that no one had expected to see in a supposedly natural body. Running along the interior of the shell, Atlas revealed a continuous lattice, a framework of plates fitted together like armour. Each panel in the lattice of 3 Atlas traced a perfect hexagon, repeated over and over with no fractures, no random gaps. Measurements showed that every hexagonal plate inside 3i Atlas shared the same dimensions down to a fraction of a metre. Reflected light returned from the edges of those plates in precise intervals, as though Atlas had been built on a single ruler. Spectral fingerprints of the material inside 3i Atlas pointed to a nickel-titanium alloy, refined beyond anything seen in nature. In natural ores, impurities smear the lines, but the alloy around 3 Atlas showed a level of atomic purity that suggested careful forging. Random accretion does not lay down seamless hexagons, and no known process in open space knits metals into a self-supporting honeycomb. The lattice turned 3 Atlas from a curiosity into a statement, a structure designed to distribute stress and survive long journeys between stars. In control rooms, someone finally said aloud what the images of 3 Atlas had been hinting at for days. Atlas was no longer plausibly a lump of frozen debris. Atlas looked like a vessel, a crafted object meant to endure and adapt. The question that followed hollowed out the room. If 3 Atlas carried such careful architecture beneath its skin, then where within that echoing frame was the mind or pilot that once watched the stars go by? For a brief span, the pulses from 3 Atlas simply stopped. The ultraviolet heartbeat that had looped around Atlas for days fell silent, leaving only background noise on the screens. For 12 full hours, 3 Atlas appeared inert, holding its place in the data as a faint, unmoving point. Then, with no warning, the trajectory of Atlas shifted by a small but undeniable degree. Tracking stations watched the course of 3 Atlas bend away from the projected path toward Jupiter. The change in the velocity vector of Atlas measured less than a single degree, but the precision of the move was impossible to ignore. Gravity and solar wind could not account for such a clean correction, especially arriving in one crisp step. Orbital models updated in real time, showing 3 Atlas turning its nose toward the outer dark, easing away from the giant planet's lane. The adjustment looked less like a stumble and more like a decision, as though Atlas had completed some task and chosen a new exit. Then, 3 Atlas spoke one last time. Sensors recorded a single unbroken ultraviolet emission, from Atlas lasting 13 minutes and 37 seconds. Within that long, soft bar of light, analysts found a faint structure, a pattern of rises and falls that resembled a binary code washed in noise. As teams compared the profile of the last signal from 3i Atlas to the known emissions of their own instruments, another echo appeared. The spectrum of the final transmission mirrored features of the very systems used to watch at last, as if 3 at last had folded our electronic signature into its farewell. For the first time, many admitted that 3 Atlas might not only send messages but also listen, reflect and reply. The idea that Atlas had answered with a kind of optical mirror held a quiet weight and attention, turned to what that reply would look like when fully reconstructed in the lab. When the final ultraviolet bar from 3i Atlas was reconstructed as an image, the lab fell quiet in a way no microphone could record. On the screen, the long-coded breath of Atlas resolved into a 3-dimensional pattern, a nested architecture of shapes that repeated as they shrank. At the heart of the visualization, the signal from 3 Atlas traced a web of hexagons within hexagons, each layer echoing the lattice already seen inside the shell. Every zoom into the data around Atlas revealed smaller copies of the same geometry, a fractal cascade that seemed to fold inward without end. Ratios drawn from the distances in the pattern around 3 Atlas kept returning to a familiar constant. Lengths, angles, and spiral arcs linked to Atlas circled the golden number again and again, the quiet fingerprint of 1.618. Mathematicians who had first measured prime sequences in the pulses of 3 Atlas now saw those primes nested inside a richer grammar. In their notebooks, Atlas became a nexus of counting, proportion, and repetition, as though someone had woven pure relationships into the light. The team behind the OEP scale was asked to revisit 3I Atlas with all new evidence in hand. With the engineered lattice, the controlled emissions, the prime pulses, and now the golden fractal engraved in the farewell, the score for Atlas climbed. When the calculation settled, 3 Atlas rose to level 9 on the scale, a place where natural origins were considered effectively indistinguishable from 0. In public, the language stayed cautious, but in private many began to speak of Atlas as a messenger rather than a machine. 3. Atlas now looked less like an isolated artifact and more like a vessel, carrying the signature of an intelligence older than any civilization we know. As Atlas turned its path toward the outer dark, attention shifted to another world along its former lane, a red planet that seemed poised at the edge of its own awakening. For months, public briefings had promised that 3 Atlas would offer nothing more than a distant show near Mars. From the outside, Atlas was described as a harmless flyby, a cold visitor that would sweep past the red planet and fade into the dark. Inside simulation labs, though, new tracking data began to pull the path of 3 Atlas closer and closer to a narrow corridor. When analysts stitched together weeks of high-precision measurements, the orbit of Atlas no longer skimmed safely past Mars. Updated calculations showed 3 Atlas passing within less than 2 million kilometers of the planet, a distance small enough to matter in cosmic terms. The gentle curve of Atlas had become a line drawn just above the thin Martian sky. To explain the tightening approach, teams turned to deep field instruments that could feel tiny changes in the motion of 3 Atlas. They found a repeating pattern of small pushes around Atlas, bursts of acceleration, arriving every 17 minutes like a slow patient drum. Rather than random jets, the thrust from 3 Atlas followed a rhythm, precise enough to keep time against atomic clocks. Each pulse nudged Atlas a little closer to a precise rendezvous, trimming the projected misdistance step by careful step. Natural outgassing should have shoved 3I Atlas in messy shifting directions, but the adjustments lined up with the plane of the Martian orbit. The more the data settled, the more 3 Atlas looked like a body steering toward a chosen point in space. In late-night meetings, people began to refer to this phase as the approach, a slow measured fall of Atlas toward a world that might not be as silent as it seemed. Radar stations listening across the solar system began to add their own layer to the story. When beams from the Mars Reconnaissance Orbiter and distant Earth-based antennas bounced off 3 Atlas, the returning signal sounded wrong. Instead of the soft blurred echo expected from ice and dust, 3 Atlas rang like a struck bell. The reflections from Atlas showed clean edges and sharp peaks, the fingerprint of hard, continuous surfaces. Technicians replayed the data, convinced the systems had clipped or saturated, but each pass preserved the same metallic timbre from Atlas. If the shell of 3 Atlas truly behaved like crafted metal, then the earlier lattice took on new weight. Atlas no longer resembled a misshapen relic. It began to read as a hull, a housing built for a purpose. Attention turned back to the jets that had been steering the path of 3 Atlas toward Mars. Detailed models showed that each 17-minute burst from Atlas pushed almost exactly within the plane of the Martian orbit. Rather than vent in random directions, 3I Atlas appeared to use its outgassing like tiny thrusters, trimming a surgical trajectory. Engineers accustomed to guiding spacecraft could not help but see something familiar in the behavior of Atlas. The small, regular nudges around 3I Atlas looked like the work of an autopilot seeking a precise corridor. In closed sessions, some scientists began to speak plainly of 3 Atlas as a probe rather than a comet. The phrase surgical intent surfaced in one report suggesting that Atlas was approaching Mars with a specific target in mind. For those watching the plots tighten, the idea settled slowly but firmly around 3 Atlas. Whatever launched Atlas seemed less interested in a random impact and more focused on a careful operation. As new data streamed in, the question shifted from whether 3I Atlas was engineered to what exactly this distant surgeon hoped to change. The possibility of contact between 3I Atlas and Mars forced planners to think beyond craters and shockwaves. Simple physics said that a direct strike from 3 Atlas would release more energy than millions of the largest nuclear tests on Earth combined. The raw blast alone would remake a hemisphere, but the deeper worry around Atlas soon shifted from rock to chemistry. Spectrographs studying the tail of 3I Atlas found traces of complex polymers chains that did not resemble simple frozen gases. Ratios of carbon and hydrogen around Atlas refused to match any catalogued body in the solar system. Some patterns hinted that 3 Atlas carried molecules that had never been seen drifting freely in space. Researchers began to ask what would happen if material from 3 Atlas sank into Martian regolith or reached buried reservoirs of liquid water. In that scenario, Atlas would not just scar a planet, Atlas could seed a world. The idea of reverse panspermia took shape a one-way transfer of synthetic or engineered chemistry from 3I Atlas into Martian environments. Data from Webb reinforced the unease. Persistent isotopic anomalies tied to 3I Atlas stood apart from known meteorites and comets, as though Atlas belonged to a different chemical tradition. If those anomalies represented tailored molecules, then 3 Atlas might function as a delivery system, not merely a visitor. In private memos, agencies weighed the risk that 3 Atlas could wake dormant ecosystems or plant entirely new ones under the thin sky of Mars. The more details emerged, the less 3 Atlas looked like a coincidence on a red target. 3 Atlas began to resemble a test, a question posed in chemistry and biology, rather than in rock and flame. As projections tightened around 3 Atlas, the tone in major space agencies shifted from curiosity to quiet urgency. Emergency task forces were formed not because anyone believed they could push Atlas away, but because time to understand Atlas was running out. Public updates grew shorter and less specific, and soon briefings stopped mentioning 3I Atlas by name at all. Behind closed doors, analysts presented scenarios built around the path of 3I Atlas. A leaked phrase from one internal document spoke of an impact protocol being initiated, hinting that Atlas now sat in the same category as existential risks. Outwardly, officials urged calm, yet the absence of clear answers about 3 Atlas became its own kind of message. While agencies managed fear, a different group focused on the shape of the journey of 3 Atlas. Cryptographers and orbital dynamicists treated the trajectory of Atlas not just as motion, but as a possible signal. They translated distances and timing into sequences, mapping key points in the path of 3 Atlas onto numbered grids. Patterns emerged in the way 3 Atlas approached resonances with Earth and Mars, as though each alignment had been scheduled on purpose. Relationships between angles and dates around Atlas could be expressed with simple sets of atomic numbers and primes. In that framing, the root of 3 Atlas read like a sentence written in gravity, a statement whose meaning depended on whether Mars would be struck or spared. For Earth, the realization was sobering. Humanity might not be merely watching 3 Atlas pass by, but standing inside a conversation that Atlas had begun long before we had telescopes to notice. As the projected path tightened, scientists noticed that 3 Atlas would pass above a single circular basin on Mars, a young plane in Elysium Planitia that glows in infrared like crystallized glass. From orbit, the ground beneath that corridor already pulsed with a faint regular warmth, as if the rendezvous had been marked long before Atlas arrived. When telescopes stacked images of 3, at last a second darker shape appeared nearby, keeping pace without following the same gravitational arc. Some called it a shadow drone, others a moving field, and began to wonder whether Atlas was only the courier for something more elusive. When researchers laid out the full journey of 3 Atlas, dates and angles began to cluster around old astronomical resonance points rhythms that ancient skywatchers once traced in stone. Each close approach of Atlas to the inner planets fell on harmonics long woven into myth. Neuroscientists then found another echo. During controlled meditation experiments, brain activity in volunteers subtly synchronized with the 17-minute cycle first seen in the gas pulses of 3I Atlas. It was as if the timing field around Atlas brushed not only orbits, but thoughts. As concern over the approach grew, a quieter signal rose from within Mars. Orbiters detected a sudden increase in xenon isotopes, leaking from beneath the crust, as though ancient reservoirs were being gently stirred in sync with 3I Atlas. Magnetometers then registered a structured pulse repeating every 17 minutes, a heartbeat, buried in Martian rock that matched the propulsion rhythm once seen from Atlas. To some, the planet seemed to be answering 3 Atlas not in light or radio, but in the slow language of its own interior field. Near the projected encounter window, light from 3 Atlas began to flicker, in layered sequences stepping through the Fibonacci pattern, like a slow recursive breath. Mapped in time, the glow of Atlas looked less like spin and more like a clock marking out eras. Low-frequency instruments listening beneath Olympus Mons caught a rising infrasound spiral that mirrored the waveform from 3I Atlas. High-resolution images then revealed an eye-like motif etched beneath drifting dunes as if the planet had been waiting for Atlas to arrive.